Good morning and once again welcome to my YouTube channel, Pearson Edexcel International Maths by Mr. Kamotho. And in this video, I want us to continue understanding integration. And we are discussing subtopic called integration by parts. And we'll be looking at question, or rather example number 12 of Pure Mathematics 4, that is IAL, and we are on page 79 discussing example 12. And in this example, we extend our knowledge in integration by parts, and the question is, evaluate the integral of natural logarithm or ln x from 1 to 2 as limits with respect to x, leaving your answer in terms of natural logarithms. And one thing you must know, because we are talking about integration by parts, we would want to rewrite this question in this way: the integral between the two limits ln x, of course you multiply by 1 dx with respect to x. The reason why I have multiplied by 1, it changes nothing, the same value is retained. Number 2, we must capture the presence of u and v, the presence of u and dv dx. And in this case, because we have two terms, this is one term and this is the other term, then I would go ahead and say, let u be ln x, u is ln x, and therefore du dx is of course 1 over x. It goes without saying. At the same time, dv dx now becomes 1, the other term, and therefore v is so much equals to x. And of course, we know what happens after there. The integral becomes now uv minus the integral of between 1 and 2 of v du dx, of course with respect to x. That way, we are now going to substitute what we know, and the integral is going to be u, which is ln x, and v is obviously x. So it's going to be x ln x, apply the limits, minus the integral of du dx, v du dx, v du dx, 1 over x with respect to x. Of course, it goes without saying that the integral is going to be x ln x with limits again, minus the integral of this x cancels with this x, the integral of 1, of course the limits maintain, the integral of 1 dx. Now, we are very much confident that the integral of 1 is simply x. So we are going to have x ln x with limits minus x with limits. And that is exactly what we are having. So when we take x to be 2, so we are going to have the integral to be equals to 2 ln 2 minus 2 ln 2 minus 1 ln 1. Of course, we all know ln 1 is equals to 0, so we have nothing to do with. But anyway, we can just put it here, 1 ln 1, just for continuation purpose, minus, of course, x, x which is 2 in this case, 2 minus 1. And that is it. So 2 ln 2 is simply 2 ln 2 minus, because we know ln 1 is always equals to 0, so this term is nullified, is equals to 0. So we have the final integral to be equals to 2 ln 2 minus 2 minus 1 is simply 1, and that is it. So at the end of the day, in a nutshell, the final integral becomes 2 ln 2 minus 1, and that is the final submission for this particular question. Once again, visit my YouTube channel, subscribe widely, and of course press the bell so that you are notified every time we upload a video. We are walking together, and we continue walking together through this journey of understanding mathematics. Thank you, and let us be on the lookout for the next video.